Good evening, Jati. Good evening, my dear friends and my dear family members. Welcome back to your channel of learning mathematics. Today we'll continue with class 12. So in the last video, we finished up integration of special functions or some particular functions. Today we will be doing exercise based on exercise 7.5, integration by partial fraction. So if you remember, I told you that we were learning three special methods of integrating. One was by substitution, the other one was integration of particular functions, and this is the third one, that is integration by partial fraction. So today we will continue with integration by partial fraction. I believe all of you are ready with your pen, paper, textbooks, notebooks, rough books, everything. So I guess we can begin now. Integration by partial fraction. Integration by partial fraction. So this will be one of the last procedures of integrating, last methods of integration. After that, we'll be jumping very soon to definite integrals also. Of course, after that, we have one more special integral, special type, that is integration by parts after this. Good evening, Rahul. So, chalo, today also let's begin with our next session, the next part of exercise of integration, exercise 7.5, partial fraction. This is a very interesting method, as I said in that last video, a very interesting method, very nice ways of integrating, different problems and all. So this method is generally used for integrating where we have to find out the integrals of rational functions. Okay, rational functions. Remember in differentiation, we had this product rule, we had this quotient rule. So this is not exactly that, but yes, these are tools because just like in differentiation, like in differentiation where we have the quotient rule, we do not have the quotient rule in integration. So that's why we have these special methods to help us solve or simplify integration. So this is one method, a very good method to integrate rational functions. It's not that by this method only we can integrate rational functions. By the way, what are rational functions? Any functions which are of the form p by x, q by x. Of course, condition is q by x should not be 0, because if it's 0, we know what happens, isn't it? It becomes undefined. So for example, just an example, x plus 1 divided by x squared plus 1, functions like this where it's of the form p by q. So we have other methods also, certain questions like this, 2x by x squared plus 1. So for integrating this kind of functions, of course, yes, we do not need to do by this method, because this kind of problems can be easily done by substitution method. the previous exercises and all we have done. So these questions can be done, but there are some questions which cannot be done by substitution methods, like questions like 4x plus 1 divided by x plus 1, x plus 5, maybe whole square. Now if you have questions like this, functions like this, can substitution work here? Possibly not. So it is where this process comes in very handy for us, that is integration by partial fractions. So that is what we will be learning here. So another tool in our armory to do integration. So we have been learning so many tools. This is one more armory. But of course there is a condition, that is this method is possible only for fractions which are proper fractions. Okay, proper fractions. This method is generally applicable or more useful when you have a proper fraction, not an improper fraction, unless you convert that improper fraction to a proper fraction again. But again, question is, what do we mean by a proper fraction? Certain things goes out of our mind most of the times. Now, anyway, no problem. I can just tell you, those who might have just momentarily forgotten. What do you mean by proper fraction? A proper fraction is that particular fraction in which the degree of the numerator is always less than the degree of the denominator. That is, a fraction in which the degree of, if we consider this to be the function, in which the degree of the numerator should always be less than the degree of the denominator. Those kind of fractions are called proper fractions. Proper. Example, x plus 1 divided by, just an example, x squared plus 1. So this is an example of a proper fraction, because what is the degree of this polynomial here? This is not an equation, polynomial, isn't it? The degree of this polynomial is what? 1. Because we look at the variable highest power, if you remember now. What is the degree of this polynomial? 2. So definitely the degree of the numerator is of course less than the degree of the denominator. And so that's why these kind of functions can be called as proper fractions. And that means what will be an improper fraction? An improper fraction would be that in which the degree of the numerator is either greater than or equal to the degree of the degree of the denominator. Example, I can do it here itself. X squared plus 1 divided by x squared plus 1. Degree is 2, degree is 2. It cannot be equal also. Then it becomes an improper fraction, or when the degree is even higher again, 3. So these kind of fractions are called improper fractions. Of course, they can be converted to proper fractions. Remember, I think in exercise 7.1, 7.2, where we have done, so where I have told you there are ways. How do we convert this improper fraction to proper fraction? By long division method. By you can divide, and then we will be able to convert it into proper fraction. But okay, that's not our job now. So the condition now, that is some conditions for us to apply this integration by partial fraction is, first, the fraction that you have should be a proper fraction. First, the fraction that you have should be a proper fraction. Second, the denominator. The denominator, these are just some, some tips or some hints. Denominator should be factorizable. F-A-C-T-O-R-I-S-A-B-L-E. Denominator should be factorizable or at least reducible. R-E-D-U-C-I-B-E-L-B-L-E, reducible to a quadratic. D-R-A-D-I-C, or at least reducible to a quadratic function. Then only this method will be applicable. Okay, so we will see now how do we apply this method. There is a small process, small algorithm we say on what to do when you have those different varieties of questions. How to do, what to do. But long division method, no, not today. We will do long division method maybe some other class, maybe for class 9, 10, maybe that time. Today, of course, we'll be doing integration of class 11. So basically, I would assume that most of us we know long division method. If not, definitely some other day we will do that. Today we'll just focus on this integration, exercise 7.5, integration by partial fraction. Of course, we might come across some questions we do not know. Now, how do we apply this method of partial fraction? Just to help us, there are some small tips which will help us in the process of integration for this partial fraction. First one is we will be focusing only on the denominator. Okay, only on the denominator. Maybe something like this I will write down, denominator. And if the denominator is of this format, what will you do? Okay, so we'll have a small table, denominator, and how will the corresponding partial fraction corresponding partial fraction. So how the corresponding partial fraction would respond. But as I said, it will, of course, when we do the exercises, it will be better, it will be more clear, but at least it will give us some idea, because based on this we will be continuing. Like first one, if the denominator is simply a term like non-repeating simple term in the form of x minus a, like for example, like you have 4x plus 1, let's say 4x plus 1, just an example. So in that case, what you will do is, how will you reduce it, or how will you do? You will be writing in the form of a by x minus a. Just note it down. When we start with the exercises, you will be very clear with this. Second, we call it, if you have product of two factorized terms like x minus a, x minus b. So that time, you will just do it like a by x minus a. You write it in this form, by b into x minus b. This is the format which we will be using. So you can just note it down, we will discuss that very soon. Third, let's say if it is repeating, let's say a x minus a whole square. That time, what you will do is, you will continue a first, x minus a, again you will continue b till it is reduced completely, b x minus a whole square. And another one, number 4, many variations. There is, for example, x minus a. X, not only minus, it can be plus also. This is just a model that I'm giving you, okay? Like whole square. That time, what we will do is a by x minus a, done. Next, you will continue with this as a repeating term. That is b by x minus b plus c by x minus b whole square. I mean, still it is completely done. This is the process that we will be adopting. Some of you may be confused, okay, what is going on here? Don't worry, when we do the exercises, things will be very clear. So in terms of simple factorized terms, we will be adopting this procedure. And the last one, that is number 5, if the denominator polynomial cannot be factorized further, and then it ends up being like a quadratic equation. For example, like x squared plus 1. So x squared plus 1 cannot be factorized further. So this remains like a quadratic equation, denominator. In that case, what we will do is, we will be writing it in this format. That is ax plus b divided by ax squared plus bx plus c. And then, of course, we will find out the coefficients a, b, and then we'll simplify. You will see that this is a very beautiful procedure. Don't worry, you will get to know that very soon. This one, you just write it down. You'll get used to it. Don't worry about that. Alright then, so I'll rub it off then. So with that, let's try to solve some exercises, solve some questions from the exercises. As I said, it will be very clear to you when we start solving the questions. Number one, we are supposed to integrate this function x by x plus 1, x plus 2 with respect to x. Of course, always do look out whether it can be reduced or not, or can we do it by substitution or not. Only if, when it is not possible, yes, definitely we will go to this procedure, integration by partial fraction, So, if you look at the table now, the table that we have, what will we do? Non-repeating, separate terms. So what will we do? We will assume this term, x plus 1, x plus 2. Denominator only. Don't focus here. Okay, focus on the denominator only. This will be written as, if you look at the table, if you have two separate terms, non-repeating terms, then we will write a by x plus 1 plus b by x plus 2. You will see that this value of x will be distributed or separated or factorized so beautifully at the end that integration becomes so simple. You just have to follow this procedure. Because see, when we look at this at the moment, it is somehow not impossible, but somehow it is going to be difficult to integrate this particular function at the moment. But what this procedure will do is, once we adopt this procedure and we solve, at the end of the result, you will see that it's very fascinating that this whole integration, which looks very complicated to integrate, at the end you will find it was very simple. We just adopt this simple procedure of integration by partial fractions. So this is the first adoption that you will do, first procedure that you will adopt. So forget about the numerator, okay, whatever it is, do not write it here, just write the constants, a by b by c, d, it might go on. Then next, our job is to simplify. Our job is to simplify, solve these equations and get the coefficients, constants a and b. Maybe we can mark this as equation 1, no problem, so that we can later on come back to this and then substitute. So common LCM, I hope you can get that point. Okay, this one let me just solve and show it to you. Here I'll take the LCM, I'll solve. My job is now focus on finding out a and b. That is something like breaking this x apart. So common LCM is x plus 1, x plus 2, a into x plus 2 plus b into x plus 1. Now common LCM, so x will be equal to a x plus 2 plus b x plus 1. I'll just write one more equation. See, equation numbers, that's up to you. It's not completely up to you. Equation number 2, 3, wherever you feel convenient, you just keep on marking where you might feel that, okay, this I might come back, I'll have to solve again. That's up to you. Actually, we can multiply and compare the coefficients. Two methods are there to find out values of a and b. I'll show you both the methods, but let's first do this method first. How to find out a and b. So the first way of solving a and b is if you have especially these non-repeating terms. If you have these non-repeating terms, what we can do is, in equation 2, remember my job is to find a and b. So now what I'll do is, putting x equal to, so if I want to find a, I will remove b, that is by substituting x as minus 1, just for the sake of finding out a. So if I substitute x as minus 1, what will happen to equation 2? Then equation 2 becomes x is minus 1, a minus 1 plus 2 plus this becomes minus 1 plus 1, 0. So then we have minus 1 equal to a into 1. That means a is minus 1. That's how we can easily find out also. But this is applicable only when the terms are repeating. Non-repeating. For repeating terms, we have to solve, compare, and then get the coefficients. Similarly, putting x equal to, this time I want to solve b. So I will reduce a. So if I put x equal to minus 2, this works out here only. Then what will happen? Minus 2 equal to, this goes because minus 2 plus 2 0. plus b into minus 2 plus 1. So that means minus 2 equal to b into minus 1. That means b equal to 2. So very easily we have our values of a and b. Alright, so that I'll wrap it off now. So I hope you remember what was our equation 1, or what was our equation 1? So x by x plus 1, x plus 2 can be written as a value 1 by x plus 1 plus b value 2 by x plus 1, x plus 2. A value I think minus 1. A value was minus 1 if I'm not mistaken. A value was minus 1. So now, this is just for our sake, okay, just for verifying. Don't do this again, just like in the last videos I told, time and again if you get time, just verify. Remember, we are distributing, or we are just breaking apart this x in this format so that integration becomes easy for us. That's what we are trying to do here. So, just rough, if I take the LCM again, it was a into x plus 2 plus b into x plus 1, wasn't it? So a value is minus 1, b value turned out to be 2. Forget about the numerator. So minus x minus 2 plus 2x plus 2. 2 cancels. 2x minus x, x. Don't we have x here? You're supposed to have that x here. You're not supposed to change the question or the function, isn't it? We're just balancing out, separating them, so that our integration becomes easy. Bus. So you can always verify. Then my integration I will now become, I'll just write directly. So this can be just written in this form. That is minus 1 by x plus 1 plus 2 by x plus 2 with respect to x. So that can minus 1 by x plus 1 with respect to x plus 2, 1 by x plus 2 with respect to x. And you will see that this is nothing but, we have already learned about this, so I'm not going to do it again, plus 2 log of x plus 2 plus c. So you can see integration has become very simple and easy. Integration done. So and of course you can modify a little bit, that is log of x plus 1. 2, as we know, can be now written as x plus 2 whole square plus c. Now we can use this bracket. Generally we use this modulus sign just to see to it that the log value is defined only for positive values. But square of any number is positive, so that time of course you can write this bracket also, round bracket also, no problem with that. Because we know that it's going to be a positive value. So we just modify, just arranging like x plus 2 whole square minus log of x plus 1 plus c. So this can be written as log of x plus 2 whole square divided by x plus 1 plus c. Because I believe this concept you know, isn't it? In the logarithm, that is log m minus log n is nothing but log m by n. Alright, so this is what can be done. You can, this value should be positive, so if you wish you can write that also. This absolute value simply means, positive values. Positive. It has to be positive. That's what we are trying to say. Positive. Because log is defined only for positive values, not for negative values. Now, got it, no? So you can take a moment quickly and see through the first problem that we have done just now. Remember, beginning part function seemed to be almost impossible to solve, complicated. Now x by x plus 1, x plus 2, integrate, how do we integrate this? Integration by partial fraction. So we start the procedure. We just have to remember the algorithm that I gave you, the table that I gave you, repeating, non-repeating. That will come slowly, don't worry about that. And once we start the procedure, what happens? We reduce that value x in terms of a and b. We simplify, and at the end what do we get? That x is reduced into such simple functions. So the entire big function becomes so simple to integrate, and then we just apply integration, done, job done. And this is the basic idea of this particular chapter, this particular exercise, how to make your integration much easier, not more complicated. These are tools, remember. Why do we use tools? We use tools to make our job easier. Simple as that. You should never treat these methods, procedures as difficult methods, difficult procedures. No, these are methods given to you to make your job much easier, not too complicated. Always remember that. So you should take it very happily that okay, I'm getting another procedure to make my integration, differentiation much easier. Always positively, not negatively. People will tell you many things. Never take things negatively. Alright, go to question number 2. 1 by x square minus 9. So here of course we will try to focus only on the integration by partial fraction procedure only completely, okay? So as I said, we should always try to reduce or factorize the denominator. Substitution, I don't think it will work. So that is always the first key. So fine. What I can do is, I'll just write here. I can do is 1 by x square minus 9. Class 12 standard, I believe you will understand. I can write this as directly x plus 3 into x minus 3, because x square minus 9 is 3 square, so a square minus b square formula, a plus b into a minus b. Now you can see that my denominator has been factorized into non-repeating terms. So just like the previous problem, when it's non-repeating terms, what shall we do? Let 1 by, here no numerator also, I mean 1 is there, x minus 3 will be equal to, as usual, a by x plus 3 plus b by x minus 3. You can mark this as equation 1. So let's quickly do it. So then this implies 1 will be equal to a into x minus 3 plus b into x plus 3. I'm not solving the LCM numerator, that we already have seen in the first procedure. We can just cancel them, finish, job done. Now if you wish, we can solve in that other method that I told you, in my first method. So I'll just put, I want b, I want a. So b instead of x, I'll make it disappear, so minus 3. So putting x equal to minus 3, what do we get? We get, let's say equation 2. So putting x equal to minus 3, if you wish to be very specific in equation 2, what do we get? We get, here nothing changed, no change, 1 will remain 1. Here a minus 3 plus this minus 3 plus 3 0, so b 0. 1 equal to a minus 6, that means a is equal to 1 minus 1 by 6. So the value of a that we get here is minus 1 by 6. Okay, na? Alright, so I'll just do it here, okay? So a value we already have. I have a tendency to forget once I rub it off from the board, so I'll try my best not to rub the important things. You must have already observed that from the previous videos and all. Okay, so next, to find out the value of b, I need to remove a. So yeah, here if we put 3, gone. So I'll just put x equal to plus 3 in equation 2. Then what will have? 1 will remain. 1, a of course this time will disappear, because 3 minus 3, 0. 3 minus 3, 0. So plus b, 3 plus 3, 6. So 6b, so that my b becomes plus 1 by 6. So b value is plus 1 by 6. Okay, so now we can go back to equation 1. So from equation 1, a value, how much? Minus 1 by 6. B value, 1 by 6. So again we see that integration becomes easier. So then, so I will be integral of minus 1 by 6 of x plus 3, I'll do it directly, plus b value 1 by 6 x minus 3 with respect to x, so that's going to be minus 1 by 6 integral of 1 by x plus 3 with respect to x, plus 1 by 6 integral of 1 by x minus 3 with respect to x. This is now not needed. So then this will be minus 1 by 6 log of x plus 3 with plus 1 by 6 log of x minus 3 plus integration constant. So minus, just arrange, we can do it directly also, but just to not create any confusion, I'll just arrange plus minus. Not necessary that you have to do it like this. If you can do directly, no problem. Just so that you don't get confused, that's why. So that will be 1 by 6 log of x minus 3 x plus 3 plus c. So this is what we will be doing, okay? Alright, one more problem. I'll just, if this is done, let's go to question number 3. As I said, do not focus on the numerator, denominator. Of course, the only thing you have to check is it a proper fraction or not? As long as it's a proper fraction, forget it. Now that, because that is not going to play a big part. Just for verification only. Because that is what we are trying to get rid of. So 1, 2, 3, 3 non-repeating terms. So A, B, C, bus. A by x minus 1. B by, let's do it quickly together, C by x minus 3. We can mark that as equation 1. So then that implies 3x minus 1 is equal to A, x minus 2, x minus 3 plus B, x minus 1, x minus 3 plus C, x minus 1, x minus 2. We can mark that as equation 2. Now, yeah, we have 3 terms, so let's simplify this. This is going to be a good job in our hands. Putting x equal to, what shall we substitute? If I want to get A, I have to remove, okay, we will see multiplication. Yeah, you don't want to do such a long multiplication because this, especially for non-repeating terms, this is the best way, because multiplying, comparing the fractions, that takes a long time again. I mean, it consumes a lot of time. So definitely we will do by comparing the coefficients, because there are many other problems which we will be utilizing, which we will be doing. But we'll just do this by substitution method, no? By putting in our prescribed values. You will see the difference, because you multiply, compare, yeah, it's going to take a long time. So definitely we will do. So I want to make B and C disappear. Common term, x minus 1, x minus 1. So if I put x equal to 1, disappears. So x equal to 1 in equation 2. What do we have? 3 into 1 minus 1 is equal to A into 1 minus 2, 1 minus 3. Plus disappeared. So 3 1s are 1 minus 1, 3 minus 1, we have 2. That's equal to A into minus 1 into minus 2. So that will be twice of A equal to A, what? A, 2. So A equal to 1. I'll write here again, otherwise I forget a equal to 1. Alright? Okay, so we have our value of a. If you're done, now I'll just do it here again. Now this time putting x equal to, I want to make a and c disappear. So 2 common there. X minus 2 is common. So this time I'll use x equal to 2. So this will be 2. So a gone. B 2 minus 1, 2 minus 3 plus gone. So 3 to 6 minus 1, 5. B into 1 into minus 1. So then directly the value of B will be minus 1, 5. So that will be minus 1 by 5. So B value, I'll just simultaneously write here, okay, A equal to 1. B value I get minus 1 by 5. Alright. Okay, now continuing. Now this time I want to find out C. That means I have to remove A and B. So common factor x minus 3, x minus 3. If I introduce x equal to 3, job done. X equal to 3, 3. So that will be gone. 3 minus 1, 3 minus 2. So 3 3s are 9 minus 1, 8. C into 2 into 1. So we shall have twice of C equal to 8, which means C is equal to 4. So from 1, 3x minus 1 by this can be written as 1 upon 1 upon this minus 5. B was I think minus 5. Let me check. Sorry, B was 1 by 5 or minus 5? If you put 2, this is really not good. 2, so what do we have? 3 to the 6, then we have 5. So B would be 2 minus 1. I'm just checking once. It cannot be 1 by 5. I'm just having a doubt. 2 minus 3. So B was minus B. Yeah, so minus 5. So B was not 1 by 5, B was minus 5. B was minus 5. We can just make that small correction there. B should be minus 5 because we had 5 equal to minus B. So I don't know how I got minus 5, minus 1 by 5. B should be minus 5. Minus 5. Alright, so from equation 1, this is what we get. So my integration now I will be 1 by x minus 1 with respect to x minus, I'm doing it directly, 5 by 1 by x minus 2 with respect to x plus 4 by 1 by x minus 3 with respect to x. So that's simply log of x minus 1 minus 5 log of x minus 2 plus 4 log of x minus 3 plus c. So here of course we don't have a common term, so we will not bring in the powers and then solve. We'll let it be as it is. Alright. Okay, so I guess you are getting a feel on how to do this particular exercise. So it's not very difficult, absolutely not. It's very simple, very easy. Even the repeating ones, repeating factors also will be very easy to integrate. So I guess we'll just wind up our class here because I'm also quite exhausted today. So Next class we'll continue with the other problems of integration from this exercise 7.5. So alright then, thank you for all those who have joined for the classes. We'll continue with our live classes again maybe in 1 or 2 days. Okay, so do study well. If you have any problems, make sure that you can reach out to me and then you can let me know. Alright, thank you all. See you. Good night from my side.